Greetings everyone, Fro here. Welcome to the Demo Hub. In today's demo, we're going to do a tutorial of UDTFs in Python on Snowflake. Snowpark for Python is an amazing capability on the Snowflake platform to develop Python code and do transformation on your data with the speed and scalability Snowflake provides. Now, many folks who embrace Snowpark for Python are pretty familiar with what a UDF is, which is a user-defined function, and how to create and use those. But when it comes to UDTF, it might be a little bit confusing, especially for a beginner. If you're new to this, it might be non-intuitive. So what we're going to do in this demo, in this video, in this tutorial is to go really slow to unpack that with the goal that if you go through this tutorial, you will have a very robust appreciation of what a UDTF is. You'll understand the syntax of how it looks and operates in Snowpark for Python, and you will be able to jump in with the examples we go through to begin leveraging UDTFs, which is a user-defined table function for use cases where it makes sense. So very powerful. As always, we're going to leave a link to the documentation if you want to go on to the Snowflake website and read the documentation. As always, we're going to leave a timestamp to the key concepts. So if you want to skip around, jump ahead, slow down, you're more than welcome to. But the goal is to really go slow so even the beginners can pick it up. But if you're a little bit more advanced, you can skip to the sections that make sense for you. That said, let's jump into the Snowflake Snowside UI. And this is where we're going to begin doing work. Now, before we jump into creating a UDTF, let's understand the data set and the scenarios where this might be relevant. To do that, we're going to create a new worksheet. And for this, we're going to use a SQL worksheet. Call this data generator. This is just to create a data set for us, which we're going to use. For this, I already did some work and some heavy lifting. You can ignore the code here, but essentially what we're going to do with this is generate 10,000 customer transactions into a stores table. The exact syntax of the data we're generating is not as important. What is very important is the data set we have. And we're going to take a look at what that data set looks like. Do a select star. Obviously, we want to do a limit of 100 just to see the format of the records we have within that table. So pretty similar to what you expect from a transactional database. You have the store location, you have the name of the store, and then we have a transaction date. So these are transactions that are coming through, the quantity of this transaction, and the price. So you can have a situation where on a given day, there are multiple transactions for a store. As always, we might want to roll up transactions to a particular store, or we might even want to roll up transactions to a particular location. So something very common within the data warehousing world. Let's take a look at this, how many records we have. Goal for this is not to test for performance. The goal for this is just to test for the syntax, and we can always test for performance a little bit later on. So here we have just the 10,000 records we've created. But what's very important is that the syntax and the format of the data is pretty representative of what we want to do. Now, to take advantage of this, we can always write group by statements in SQL that will go in and take a store and do a group by the price to see how much sales is happening at that particular store. Obviously, multiply the price by the quantity and you'll come up with your total sales figure. So pretty straightforward, something we can do in SQL. But obviously, we can also do this in Python, and that's what we're going to show. Again, the motivation for this is not to say Python is the only way we can solve this problem. The goal is to show how if we were going to solve this in Python, one way that could look like with the UDTF, and then you can always apply this to the situations that make sense for doing aggregations, training machine learning models, and really taking advantage of the parallelization that Snowflake provides with the TF. Now, here is the data set we have. Let's go back and begin creating a UDTF. Now, to create a UDTF, we're going to do this within a Python worksheet. So go ahead and click on the plus sign, click on Python worksheet. Here we have our plain vanilla Python worksheet to go with. Now, this is where we can begin authoring the UDTF. Now, a couple of things we're going to do here just to start from scratch is I'm going to go ahead and delete everything within the Python worksheet. And we're going to see how to create a UDTF from scratch. This allows us to do that. So give this a name first, as always. So this is a UDTF, and we're going to call this Python store sales. So this is the code that will allow us to do our Python store sales. Here, The vanilla code gives us the import Snowflake SQL, Snowflake Python. Obviously, we need that. We're also going to get the functions, import columns. Those are the standard imports that comes with. But we're going to jump in and see how we can begin creating the UDTF. So obviously, a UDTF is a little bit different than a UDF. If we were creating a UDF, this would suffice, right? We can just come in, use what was in there, give a function name, make sure the function name matches the handler, and that is it. And you can create as many UDFs as you want. But the UDTF is a little bit different, and that's where we're going to see some of those syntax differences. So to begin creating the UDTF, the syntax is a little bit different. For that, we're going to need a couple of things. The very first thing we're going to need is a class. Go ahead and call this store sales sum. And the goal for this is to take our store sales and sum that for each store location. And obviously, to sum up the sales, we're going to multiply the quantity times the price for that store. So group by the store and then sum that up. So pretty intuitive what we're trying to do here. So here, obviously, we're going to do a def. And of course, we're going to do an init for this. And you can see Snowpark Python worksheet really allows us that syntax highlighting autocomplete and very beautiful interface to type with. So the very first thing we're going to need here is just to declare a simple variable. But before we declare this, let's talk about a couple of things. What we need for a UDTF is a little bit different than what we need for a UDF. So for UDTF, we're going to need an init function. We're going to need a process function. And then we're also going to need the end partition function. So let's just put a placeholder here. So call this code. So we need the init, that's for sure. The next one we're going to need if we're creating a UDTF is, and I'm just going to paste this all here, and then we'll fill in the blank. So we need that init for sure. We need the process. And then last but not least, we need the end partition. And I'm going to talk about what all of those mean. So init, process, and end partition. So delete this, and we'll fill in the details of what we need for both of this. Now, what is the init? To be honest, the init is optional. You can always skip this, but if you think about it, it's just any variables that you might want to need or you might gonna use in your process. So this is what will be in the init, right? If you have no variables that you're gonna need, then you can keep that. You can leave that blank. You can just delete that as well. And then the process is where the job actually happens. So this reminds me of a long time ago with Hadoop and MapReduce. If you remember, anyone who's worked in the world of Hadoop and MapReduce, you had this idea of the mappers and then the reducers, and then obviously there was combiners and a lot of different things in there. But essentially what the mappers would do is the processes that does the work and then return the results to you. And we're spending some time here just so we can get intuitively what this is actually doing. To give an analogy, is think about if you are trying to take the United States, for example, you're trying to calculate the total population of the United States. One is you can go around and go from state to state and run a census that counts every user in that state and tally them up as you go from one state to another state to another state, right? And that's a very sequential process. You can do it, but if you're not done with one state, you can now move to the next state. And if it takes you 3 minutes in one state and you go to the next state, it takes you 3 minutes. Now you're going to have to multiply 3 times 50. And that's how long it takes. That's going to be your upper bound. But what if you think about it a little bit differently, where instead of having to go from state, finish that state, go to the next state and do the count, you can send out an order where every state is simultaneously going to count the population of their state. And when they are done, they're going to send their results back to like the federal government. And then we do the tally to figure out how many users or how many people are in that state to come up with the population. So if it takes about 3 minutes for a state to count how many folks are in their state, how many people are in their state, then that's going to be the upper bound, because for everybody, it takes 3 minutes. And as soon as the 3 minutes is done, because they're doing it parallelly, simultaneously, we'll get that result back way quicker. So you're getting your results in maybe 3 or 5 minutes as opposed to 50 or more minutes, right? So having parallelism and parallelization becomes very, very important to do. We're spending some time to really elaborate on that because that's a concept to appreciate when we think about the UDTF. So the UDTF, this process that we have is where that parallelization is going to happen. So if we have a table and we are going to do a sum of those by location for a table, then we want to write the logic in here that would take the right parameters and be able to independently, parallelly calculate whatever logic we want and then return the result, which is the end partition that sums up everything and brings to us. So hopefully, once we go into the details here, hopefully that will begin to make sense. But it's very important to appreciate this little detail here, because that's really what makes a UDTF powerful. If you understand the concept of MapReduce from Hadoop, we take a look at that. All right, so this is the basic syntax. Again, we have the init, pretty optional. We have the process, and then we have the end partition. Now, obviously, if we come into the process, this is going to be an important piece. With the UDTF in Snowflake, there is a concept of return, right? So you can return anything in here. And for the return, we're going to use this keyword of yield. So yield is I'm done with what I'm supposed to do, and this is the result that I want to return back. So if there is something to return, you can return here. If there's nothing to return, obviously you're going to return a none. So for now, let's just do a yield none. Okay. But what are we yielding? We want to do logic in here that would do, and let's take this to the next line. We want to put logic in here that can calculate the sum for each store location. If we went back to the previous table we saw, we had the store location, we had the store name, we had the date, and then we had the quantity and the sale, right? That logic will have to happen in here. So let's go ahead and flush this out some more if we understand the syntax. And then obviously here, we're also going to do a yield. Let's just do a yield none for now, and we're going to change that with some more details. All right, so each store would do their process. When it's done, this end partition would aggregate from each store and then give us the final tally. Hope that makes sense, right? So think about this as each state parallelly at once, calculating the population of their state, and then it returns the result here. And that's the result that we can then tally from every state with the end partition logic here, and then return that result. And this is what a user-defined table function is going to do for us. So let's flush this out some more. Let's go into the init. What could we need for this? We're going to need a total, right? And let's just do a self and have a placeholder for this variable called total. Keep that as 0. So why do we need this as 0? And there are different ways to do this. The goal for this is not to write the most efficient Python or to write the most beautiful Python. The motivation for this is just to understand what is going on here and help you customize this and make this work for the use case and the scenarios you have. Whether you're just doing basic data engineering or you're trying to do machine learning training or feature engineering and you need that parallelization, this will give you the foundation for that. So let's do a self. This will be our total placeholder. And for now, we're going to keep this as 0. But what are we going to total, right? So this is where now we have to come back into our process. And this process is going to need a couple of things for this to work. So now that we have the total, what are we going to do with that? What are we totaling? This is where we come into the process, and we're going to write the logic for actually processing the data. And this process will run in parallel. It's very important to know that. So this is where we need some logic. And let's go out and flush this. So obviously we're going to get the self from there. Let's get the quantity. We know we wanted the quantity. And we also wanted the price. So our data set had a quantity and it also had a price. And just because we're dealing with Python here, it's very important to always put in your variables. So the quantity is an integer as well as the price is a decimal or a float. So we're going to send the quantity and the price. We'll multiply those two and return the result as a total. All right. So for this, let's go ahead and flush out this logic. What do we want in this logic? So we want to update the total, right? So what are we going to do? We're going to go total, and we are going to update the total with something. All right. And what is that something? Before we write out the something, before we fill out the something, let's go ahead and do something else. Let's do sale amount. All right. What is sale amount? Sale amount can be the quantity which we'll have coming in there, and we're going to multiply that by the price. Very straightforward. Once we have that, we can do sale amount as such. For me, we can do it this way, but we're kind of getting a little bit elementary here. So let's go ahead and just delete that. Just put it in one line and make it all one line where we are, in this case, going to get the total and multiply the quantity by the price and then just submit with each order, right? Obviously, if you want code that's more readable for you, split it out. For me, we're going to keep this simple so we're not using a lot of variables. All right, so this is our process. So this is what's going to process and do that computation for us for each partition. And we're introducing a new word here that we provide. So for each partition, we're going to do the quantity times the price. Okay, and then we're updating this total field. Now, because this is, think about it as almost a global variable, if every partition is running, right, this and update this total, we're going to get a consistent value at the end of the day, right, for that partition. So hopefully that makes sense. And then now, what is the next thing we have to do is let's come down to the end here and flush that out. So end partition. Now, once all of those partitions here are processed, how do we end it, or what do we do, right? We want to take this total that we've calculated and then return that for the partitions. All right, so here we're going to return, because this is updating the global variable, so we can yield none. So it's not going to return anything because this would be consistently true. So we can have access to this total. And so yield here is none, right? But if you really wanted to, you can write the code in a way where you yield a result and then use that for your end partition. That's really up to you. Because we have it as such, let's come into this yield for the end partition. And instead of yielding none, let's do a yield and yield the cell total. Go ahead and yield. So this is a skeleton of what we need, but there are a couple of things that we still want to flush out, because we're doing a total for store location. You can keep this as optional, but it's also important that we can introduce a store just so we can return the result for that store. So I'm going to go ahead and just include store for process. So when we call the process, we're going to obviously get the self, we're going to get the store. If you want, you can specify the data type, the quantity, which we did, and then we're going to do the store. In this case, I'm not really going to do much with it. Let's just do store for the sake of it and make that store. All right, so nothing really to write home about for that. But what we're going to do here is let's return self.store as well as the total. So the self.store and then the total for that store for the self. So that way, when we do this result return, it's going to be a lot clearer. Now, there are a couple of things that we still have to do just to make sure that this is flushed out. Obviously, here, what is the data type of the store we're returning? And what is the data type of the total we're returning? It's important to specify that. And so we're going to go ahead and specify that as an iterable. So the way UTF would expect is it's going to expect an iterable, make that an iterable. And within that, we're going to put in a tuple. Within this tuple, we're going to have to specify the return type, and that would be a string because the store is a string. And then obviously the total would be a float because we're multiplying an int by a float. So we're going to expect to get back a float as the return type for that. We have the basis covered for the end partition. Now, if you go back to our process, obviously we're getting store, quantity, and price. That's pretty good. If you want, we can always go in again and throw in a string. And then if we go back up and we double check on our store sales class as we're building up that class, we can also touch on one more thing here. If we want, is we can specify that store, which is coming true, because obviously we're referring a store here, and the store is also being referenced here. So if we don't specify a store here, we wouldn't have that coming from anywhere else. So again, pretty solid. We're going to leave the code below if you want to copy and paste. We now have init, the process that does some logic. Let's just remove other comment. I think it's understandable now. And then we're going to yield that back. Now, ordinarily, the expectation would be for us to just somehow run this code. Okay, that will be a little bit tricky because the Python worksheet allows us to go ahead and do a deploy, and this will create a start procedure. But how do we allow this in a UDTF? So this is not just a start proc. This is a UDTF that we want to have, which is a version of a UDF that can take a table and then do that processing for us. So we're going to have to register this as a UDTF. So how do we go ahead and register that? A couple of things that we're going to have to do. Number one is with the Python worksheet, we know there's always a need for that entry point. So if we come up here, there's a handler that would need to be the entry point into your code that does the processing, and then it's going to return the table. So the return type is good. There's no problem with that. We just have to specify this entry point, this main method that then would go in and do that registration for us to register the TF for us to be a process. And we can go ahead and make this into a string because we don't really need a table. We just want this .proc to be the entry point to creating the UDTF for us. So now let's go ahead and implement that main method to make it work. So I'm just going to go and do a def main. You can call it main. You can call it whatever you want. And obviously, it's going to always take a session. And that will be a Snowpark session. So pretty straightforward. Go ahead and end that. So Python is happy. And to make this work, we need an indentation there so the syntax stays consistent. All right. So now we have a function, a Python function, which we want to register as a UDF or a UDTF. And there are a couple of ways to do this. To me, I prefer the way of doing it as a decorator. I'm sure by now you already know how to register UDFs in Snowpark for Python. So just use whatever way makes sense to you. But for us today, we're going to use a decorator. So normally to register this as a UDF, you're going to do add UDF and go in blah, 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 and fill in the details. All right. But we don't want a UDF. That's a user-defined function. What we want for this to be is a UDTF. All right. So we want this to be the TF. And what is the name of that UDTF? Let's just call it totals, right? Give it whatever name you want. All right. So let's put a couple of placeholders here of what we need. So for sure, we need the name of what the UDTF would be. We need the input types, okay? And let's go ahead and specify that. I'll keep that as a placeholder. In addition to that, we're going to want to know the output schema. So what is this going to output for us? So that's going to be the output. Let's put that in double quotes. We'll come back and fill that up. And in addition to the output schema, we can also always, because we're going to register this as a permanent UDF, we're going to need a stage location. And let's go ahead and put that blank. We're going to come back and fill that. And in addition to that stage location, let's make it replace as true so that if we run this over and over again, it's going to recreate this TF called totals. And that would be true for us. All right. This is fun. This is exciting. Let's go in and fill in the details. A stage, I know I have a stage location here. And as a matter of fact, we're going to make this as the stage I have is called the fruit stage. And that's pretty straightforward to do. Let's come back to the output schema. What do we want in the output schema? Before we talk about the output schema, let's go ahead and do what that input schema would be. So the input schema here is going to take tuple. And the tuple is three things. So what are we inputting into this process? Okay, so we come down. Obviously, there is a self, that thread of the Python code. So that's the self. And then we need the store, and we need the quantity, and we need the price. So we need three inputs to be defined that's going to come in. All right. So this class, when it instantiates, is going to initialize all the variables at the class level. And then this process is what's going to take those three inputs and process them in parallel. All right. And that's why we need to specify that as the input types here. All right. And so in this case, the input type would be what? This would be a string type. And that is pretty straightforward because the store is a string. The quantity is going to be an integer type. And what is the last one? It's going to be a float. So we're dealing with a float for the last type. All right. So string for the string, integer for the int, float for the float of the price. So those are the three things we expect. Now the question is, and this is just a certain nuance that you just have to catch, is here we're dealing with the Snowpark for Python data types. That's why we're specifying a string type. Obviously, if you do an str here, it wouldn't work, right? Because that's a Python string. But here we're dealing with the Snowpark for Python string, and that's what we're specifying. We're registering this as a UDTF with Snowpark for Python. And so we have to specify the data type with Snowpark for Python. Check on the documentation and the developer guide for the supported data types on Snowpark for Python. Just double clicking on that just so it's very clear. Now, obviously, if we select this type, you see it's complaining that it's not resolving what is a string data type or what is an integer data type. And this is where we're going to have to make sure we import all of those. All right. So we're going to have to import, obviously we're going to Snowflake, and we have it above there, but I'm just going to type this again, Snowpark, and we're going to go to types. And for the types is we're going to import an integer type because we're referencing that. We're going to import a float type because we're referencing that. We're going to import a string type because we are referencing a string type. And I know we're going to need a couple more. So I'm just going to go ahead and import all the other types that we're going to need. Is a struct type, and this will come in handy here shortly. So just go ahead and import that and do a struct field as well. That Snowpark for Python provides. And then I think we should be good. Now, obviously, if you wanted to, you can just import star and bring everything. It's always not the best practice, but that's an option that's available to you. Now, we have the data types that are imported. One more thing we'll import is we're seeing here, it's telling us that we're doing the UDTF is not being resolved. So, and that's where, again, we're going to have to make sure we import that. So anything that doesn't resolve, just go ahead and make sure you have that imported. So we imported the Snowpark here, and we did the column function. So I'm just going to copy that, paste that, and instead of bringing the column, let's do a UDTF. And now that makes this a resolve pretty well. So that's all fine and good. Now let's go back. We have our input type specified. The output types is missing for us to really close the lid on this. So, and this is the output schema. All right. So what do we need as part of the output schema? We're going to need three things. So what do we need? We know we're going to yield the store, and we're going to yield the store totals. So this is what? This is a string type, and this is a float type because that's what's coming in here. All right, and we specify that. So for us to specify that return type within the output schema, it's very straightforward to do. Obviously, you can do just a return. You can say a return for the output schema, string, or it might be tempting to do something like this, string and float. Obviously, that would not get us to where we want. So the way we're going to do it, I'm just going to go ahead and there's going to be some typing here, is we're going to define our struct type, and this struct type is going to give us a couple of things, all right? So the struct type, we're going to go in there, and then within the struct type, we're going to go in and create our tuple, all right? So we need two tuples for that. One is going to be the string type, and the other would be the float type. And so to specify the string type for the field that we want is, we want a field called store, obviously, and we want another one called total or sale total. All right, so this is the two that we need. And I'm going really slow on this just so we can capture the syntax and not miss anything as you go to write the code. So here, instead of just doing store, which is not going to work, is we're going to do a struct field. So we're going to define a field within a struct data type, and that field will be where we get to specify the name and the data type for that field. All right, so we're going to need two struct fields here. So the first one and the second one would be the total. Now for that struct field, it takes two inputs. It takes the name of the field, whatever name we want. So this for us in this case will be a store, and what is the data type for that store? And this is again a Snowpark for Python data type. This is not your regular Python data type. So for this, the data type will be a string type. All right. So very straightforward. Let's go ahead and copy this and fill in the blanks for the next one, which is the store. And the field here would be, obviously, we don't want to call this store again. We want to go ahead and call this sale total, float. Data type, we've defined the return types for both the store and the float, because these are not just definitions. We're going to have to make that into a data type, add a column there, and this would be all fine and good. So let's just recap what we've done so far. We're building our way from the ground up and writing the code just so that we can have everything in place. So first, we import the things we need, make sure if something is not resolving, import that. Next is we created a class, had 3 key things within the class: the init, the process, and the yield. That gives us a class definition. Then we incorporated that within a function, a main method that can then be defined as UDTF. There is a problem here. We're saying that the iterable is not getting resolved. So if something is not getting resolved, what do? We always will go in and bring that as part of the import. So let's get to import iterable and import tuple, just so that everything resolve. Okay, so that's good. Now we have a resolving for the iterable, and we also have the tuple getting resolved as we expected. Okay, so now all the code has been written, and we are ready to execute this to create the UDTF that can then be used and invoked as a function. Now, the definition we have here obviously will not work at the entry point. We need this to work at the level of the class. So just copy that code and make sure that we bring it. It's easier to do that definition above. And when you're done, just make sure you bring that into the class. So again, to reiterate what we're doing, the main method is going to come, invoke the main method with a session. Once we go in there, we have a class defined, and this entire class is being registered as a UDTF, which will be called totals demo, and then we can just call this UDTF. So pretty straightforward and all ready to go. Now, with our code written and everything in place the way it should, let's go ahead and deploy this. So to deploy that, you can click on deploy, and here we're going to give this a name for Snowpark store sales, and I'm just going to go ahead and call that demo. Replace that if we want, and either deploy or we can open a worksheet. I love to open the worksheet just so we can always double check and verify what we have has come correctly. Snowpark sales demo is going to be the name of the Snowpark, and when that is invoked, we're going to come in within the main method and register this UDTF, and that UDTF can be used multiple times. Very, very simple, very intuitive to do. So let's go ahead and create this. It takes a few seconds. All right, that was successful. The Snowpark store sales demo has executed successfully, and the Snowpark should have been created. Now, if the Snowpark has been created, it did not create a UDF for us. So let's go ahead and double check first that the Snowpark has been created. So I'm going to go back to my databases. We're doing this within the demo public. And if we go to procedures, done this a couple of times. And what do we call this? SP store sales demo. We should see P store sales demo. That's the Snowpark. Now, if we go into functions, we don't have a UDF defined here, right? Because the user defined table function should be called totals demo, right? We don't have that showing up here. And that should take the inputs we expect, which would be a string, integer, and the float being returned. Again, that doesn't show up here. But that will show up if we execute this SP store sales. So go ahead and execute that. It should take a few seconds. That was successful. We have SP store sales executed. And the only reason for executing this is to instantiate, is to go out and to create that UDTF and register that for us. All right. And you can register as many UDTFs in here as you want, right? It doesn't have to be just one. We're doing this just for the sake of demo. So this could be almost like your UDTF utility class that then registers all the UDTFs that you want and version control that the way your coding practices allow. So let's go ahead here and do a refresh of this. Now we have the total demo, and it's going to take the argument 1, argument 2, argument 3, and then it's going to return the store and the sale total for us. Obviously, again, as we said in the beginning, the goal for this is not to write the most beautiful code, is to show the concept of what's available, and you can always make this more intuitive and clear for us. Okay, now we have a UDTF defined, but how do we take advantage of that UDTF? So if we go back into the data set we had before at the beginning when we created all those objects, we started by creating a table that had our transactions. Just to verify what we had within that table, I'm going to go ahead and select the transactions table here, limit by 100, move things to the right in here. So in here, we had store location, store name, transaction date, quantity, and price. And so what we're doing is we're taking the quantity and the price for every store, we're sending that And in parallel, we're going to partition it to say partition by store and parallelly sum up the quantity and the price for each store and bring back the result. Okay. This is, to be honest, a little bit trivia, but if you're doing a machine learning model training or something more sophisticated, you have this flexibility to do that. And that's really the essence of what we're doing here with this tutorial. All right. So now we have a UDTF, we have our data. Now let's apply that UDTF, because what does a UDTF take? It takes a table and it applies that logic to a table as opposed to a UDF that goes row by row. All right, so now let's go in and see how we're going to apply this into the UDTF. It's pretty straightforward, but the syntax is very important to grasp. So for this, I'm just going to go ahead and do something here, right? So let's just say run UDTF, because this is what we're going to do now, UDTF. All right, so select start from store transactions. We want to go to store transactions. And there are many different ways to do this. The way I'm showing now is not the only way you can do it, but be rest assured, read the documentation. There are so many, probably easier ways to do this than what we're seeing here. All right, so store transactions will give us all our transactions. But what do we really want to go after, right? Again, we're talking about a user-defined table function. So we want to go against table. And what table are we trying to go against? The table, in this case, is going to be the code that takes a table. So it's going to be a UDF that takes a table. And what is the name of the UDF? It's called total demo, if you remember the name of that UDF. So I'm just going to go ahead and copy that UDF and drop that in here into a table. All right, so that's the syntax. So table, you need that syntax. And what's the name of that table? It's a total UDF. It's a function. All right, so a user-defined table function. And then what are the parameters that we need for that, right? So obviously, just by the way we wrote the code, we don't always have to do it that way. We needed the store location, or we needed the store. In this case, I'm going to roll up by location here. So let's just, or you can roll up by store name. It doesn't really matter, but let's just do it by store location. All right. And so that table function, remember, it took 3 parameters, and those are the 3 parameters we're going to specify. Quantity, and it took what? It took price. All right, so store location, quantity, price. If we looked at the process method, so let's look at the code, store quantity, price, that process method will receive that and then process that for us. All right, so those are the 3 things here. For the sake of being very unambiguous, I'm just going to go ahead and define the data types for this. So what was this? This was a quantity was an integer, I believe. And the price was a float. And obviously this was a string. We can just leave that. But so the totals demo table is going to require the store, the quantity, and the price as we expected. But with the UDTF, the power of this is the ability to parallelize. So what are we going to parallelize? So we can have multiple rows going to that process and running at the same time. That is what we're really trying to do here. All right. And that's where you specify that as over. Anyone who's done windowing functions is pretty familiar with over. And then this is where we get to specify our partition. So what are we partitioning by? We're going to partition, in this case, by store location. All right, I'm just going by store location. For you, it could be by region, or it could be by product name, or it could be by customer name, and you're doing some customer attribution. That partition by is really up to you. Maybe in subsequent videos, we're going to touch on this, because this becomes really key if you want to see dramatic performance. How your data is partitioned becomes very important, as well as how your data is clustered already on disk in the micro partitions. A little bit of an advanced concept, but those are things that if you can dial into those, you're going to see performance gains that are mind-blowing. We're just scratching on the surface here to kind of show 101, but be rest assured, some of the dramatic results you see when folks are doing UDTFs or doing machine learning training on Snowflake, it's because of that, right? And just the foundational way of the foundational architecture of Snowflake. I know that's not the essence of this video, but if you want to get deep into that, Snowflake has the architecture and the capacity to match it. So just wanting to put that out there for anyone who is probably curious about it. All right. And so with that, we have everything ready to go. Okay. But what did they say in SQL 101? Do not write select stars. So we're not going to break that rule in this session. We're going to make sure we specify what we're expecting. And what do we expect to come back? We need a sale, a total. And I think that's really about it, right? We need the store location and then the sale total to come back from here. All right. So call that store and still total to come back. And that is really what we need. Alternatively, if I really just wanted the store location, because I have that in here as well. So if you run this, this is Python code, it's calling the UDTF, which is implemented in Python and is doing all the heavy lifting for us. All right, so the code ran successfully and we've got the results here showing with UDTF in action. So let's take a look at what this is. So we can see we're grouping by a store location. Obviously, Virginia has all the totals, Oklahoma has all the totals, and it goes on for all the 50 states has all the totals based on what we had in the data set, because we specify the partition by store location at the state level. All right, and that's why we have it as such. This is extreme. This is fast. Again, we're not showing performance here. The goal for this is to show syntax, so you can go out and create your own UDTFs. But if we really wanted to show performance, depending on the warehouse size you're using and the number of nodes you have available in the warehouse, the number of threads for each node, so 8 nodes per warehouse, you have 8 nodes. Well, depending on the size of the warehouse, you have 8 threads per node that could be used in Snowflake. And you can always go out and check out the details. So you can get some really, really amazing parallelization here, again, depending on how your data set is structured and how you can really dial into that and get some dramatic performance. All right, that's very good. Now we've seen how we can execute this with the store location and getting the result. Just one more time, again, with this store location, we're getting all the sales group by really fast. It took about 53 milliseconds here, probably coming from cache, but fast if we did it even without cache. Again, this code wasn't optimized. We're just writing the code here for demonstration purposes. But because we are not actually using the store name here, essentially we're just taking quantity and price and getting a total. This code is very flexible. So if we wanted to roll up not by store location, but by the store name, we still can do that. Okay, to illustrate that, let's go back and see what we had here in the store transactions. So we had the store locations. We saw how we can roll up to all the 50 states. That's basically the store location. But what if we wanted to roll up to store name? Again, this UDTF would allow us to do that. I just copied that previous code and then just go ahead. Very simple, right? Change the store location to what? Make it a store name and copy that and just replace wherever we had store location. So here in our UDTF, the totals demo, which is our UDTF here, you always have to reference that with the table. Now we're sending in the store name, and this is the key part. We're partitioning by store name as opposed to store location. All right, so this is our store name. So again, it takes it, sends every store into one process, and it's processing that all of it parallelly, and you can really take advantage of the parallelism from here. If we run this with any log, our group by should no longer group by the store location. We're now grouping by the store name. A lot more records because we had a lot of distinct store names here, but you get the point of what essentially is happening. Now, depending on how you architect your UDTF, you can have some tremendous flexibility on it. And if you wanted to, the beauty about doing this with Snowflake, having Python and SQL all happening in the same place is, if I'm not happy with what I'm getting here, we're doing this with a small warehouse, my demo warehouse. I'm putting that at a small. Boom, in a second, I could transform that into, I'm not going to run this with a 6XL. I could resize that into a 6XL, bring the train. So we're going from a bicycle to a train in a few seconds, and we could run the same query, right? If you were doing a machine learning model and you're training the model, or you're building or doing your feature engineering, this is where things begin to blow your mind. We're not having to wait for a cluster to spin up. We're not having to worry about all the other things. Just have your code, deploy the code, and then you can just use the flexibility, scalability of Snowflake, and it just works. And I'm doing this in the same environment where we're doing SQL, and a SQL developer can orchestrate this even if they don't know Python. To them, this could be just a function, or it could be a very powerful function, like we're saying, a UDTF, right? And having that democratization or that synergy between the Python and SQL all in one place is just the tremendous power of having Snowpark for Python at your fingertips, with the ability to do not just stored procedures, you can do functions, UDFs, and then UDTFs that can allow you the parallelization. So hopefully this was a helpful tutorial. We went slow, we took it easy, and the goal and the motivation for this was just to go from zero to beginner. And if you can follow through this, I'm going to leave a link to this code either in the description below or on the GitHub, and make the link publicly available so you can run this and get that experience creating your own EFs. What I'm very curious about is how you can extend this beyond these simple examples to sharing your own use cases, maybe challenges on how you're applying this. And I'll be more than happy to help and answer and respond to any questions or issues or comments you have about UDTFs on Snowflake. And in the next couple of tutorials or demos we're going to do, just based on popular demand, we're going to go in and touch on vectorized UDFs. We'll spend some more time on optimizing and dialing in on UDTFs and a whole lot of other topics. So don't hesitate. If you have any areas or topics you want me to jump into, make a demo, or give a commentary about, I'm more than happy to do so. Links to all of this will be in the description below. I always recommend just go ahead, read the documentation. There's no better source of truth than the documentation. There are good examples there, very easy for you to follow. And if you have any questions, again, as always, let me know in the comment section below, and we'll see what we can do. Again, thank you so much for sticking to the end. I have been your host, Fro, here with DemoHub. Really appreciate you and the time, and I'll see you in our next demo.